morning. Thanks, Rajiv. Yeah, my name is Troy Sargent, and today I will be talking about Slither, a Vyper and Solidity static analyzer. Um, a little bit about me. I'm a security engineer at TrailBits, so I work on smart contracts, blockchain nodes, rollups, virtual machines. I contribute to Slither, and there's my handle for my Twitter and GitHub. If you're not familiar with TrailBits, we combine manual review with practical program analysis. So what that means is that we apply fuzzing and static analysis to pretty much every language and platform that we work on. And there I've listed a few. So first, what is Slither? Slither is a static analysis framework for smart contracts. So it can do three things. We can find vulnerabilities, we can find optimizations, and it can also help us to quickly get insights into code so that when we're doing an audit or security review, that we can be productive more quickly. And if you're not familiar with static analysis, that just means that our technique of choice, rather than executing the code and running it in the Ethereum virtual machine, instead we look at the source text of the program and we answer questions, and based off of just purely syntax, we can understand the behavior of the program. And so there I've linked to the GitHub and how you can install Slither. It's a public tool, free to use, so you can check it out afterward. Yeah, and so today I'm happy to announce that after a long wait, that Slither now supports Vyper. So if you look back, I think people have been asking for this since about 2018. And if you're not familiar with Vyper, it's also a smart contract language like Solidity. It's very Pythonic. It looks just like Python. And so this August, we worked with the Vyper team to add initial support specifically for the 0.3.7 version of the language. So we worked with them on 3 different code bases, from Yearn, Curve, and Lido, to get this initial support for the language and continue working on it from there. The amazing thing about this, and sort of strength revealed of Slither in this, is that it required very little changes to the 90+ existing detectors that we have for Solidity. So we were able to drop Vyper support in, and for free we get all of these vulnerability and optimization detectors and other tooling around Slither without a whole lot of work. And as a bonus to static analysis support, we now can also fuzz Vyper with Echidna and Medusa. So today, I just want to give a quick intro to Slither for maybe people who are unfamiliar, and demonstrate how you can find bugs and explore Vyper code bases with it, and then sort of a more advanced tips, how you can use Slither more effectively if you're familiar with it. And unfortunately, just due to time, we can't go into the really low-level details of how this was actually implemented. But if you're curious, you can find me after the talk. Yeah, so we're going to go through how you can find vulnerabilities and understand code. So first, finding vulnerabilities. So this is a simple Vyper contract, and we want to know if it's vulnerable to reentrancy. So we run Slither and we ask it, will you look at this file and will you detect reentrancy? And not a surprise that this withdrawal function is indeed vulnerable. So we get this diagnostic saying, here's a bright red warning saying like, this is really bad. You have a reentrancy vulnerability. You should probably fix it. And this is just like one of the many detectors of the 90, just as sort of a the last defense, that after you've tested and reviewed your code, you can also automatically check it for really critical vulnerabilities. And this is not the only one. Like reentrancy is pretty well known, but there's also again 90 something other detectors that you can also run as well. And so this snippet on the slide is not particularly important, just kind of demonstrates that code can be kind of overwhelming and complex, and when you're looking at a particularly large code base, getting a grip for like what is important to understand about the code, and what are the features of the code, and like things that I should understand about it can be particularly challenging. And so one thing with Slither is that we have these things called printers that very quickly give you insights into functions and contracts, and you don't have to know anything about the internals of the tool. They're just for free. They come out of the box with like some pretty powerful analyses that just give you answers to questions that are particularly important to you as a security researcher or developer. And so the one that we'll cover here is called the Vyper and Auth printer. So it will show you two things. It will show you what state variables each function updates, so it writes to the state variable. And then secondly, it will show you uses of the sender, message.sender. So this is of particular interest because generally this is used for authorization. Like the developer might be trying to make sure that the sender is the owner, and like if you're not a privileged user, then you shouldn't be allowed to perform this operation. So from the last example on the slide, we kind of get this condensed look of the code saying that the state variable written was admin balances, and the condition on message sender is that it just calls transfer from on it. But from there, we can sort of infer that in order to successfully call transfer from right, you must have given a prior ERC20 approval with the adequate amount, otherwise it would fail, right? And so we can very quickly get insight, but Solidity code bases are much larger than one function. We might have 50 contracts with dozens of functions each, and so this can maybe be overwhelming to, you get this long verbose output in your terminal. So one thing I've kind of been toying around with is, how can you make this more digestible you have a lot of this information, but you might not have access to understanding it. And so one thing that is sort of experimenting with is creating sort of a query from this. So here you just use some command line magic, and you say, okay, we have the output of the printer. We're going to pipe it into this command line, and we're going to say, we're going to search for this variable is _killed. And so what we get back out of the potentially long output is a condensed view, and we can see that only two functions actually write to this variable. And the thing that's interesting about this is we can see that the conditions on the message sender for both of them is that they must be equal to the owner, otherwise the function would revert. So in Vyper, assert is equal to like Solidity's require statement. And so this can very quickly help you identify that this variable is something that only the owner should have access to write to it. And also we can correctly identify that there aren't instances in the program where you can write to it without being the owner, because we've checked the conditions. So we can kind of mentally check that off of like a potential attack vector, and just we've also gotten insight into one of the important intentions of the developer, that there is some level of access control, right? And so beyond just using Slither to understand code and find vulnerabilities, I want to also offer to you 2 tips to use Slither more effectively, how you can be productive, right? Static analysis tools are sort of notorious for having false positives, and there's this thing in a lot of research called like fatigue or static analysis fatigue. Like you just get tired of warnings and such. And so one thing I want to offer is like, how can you as a developer or a security researcher get use your time most effectively, right? And so what I'd like to offer as a tip number 1 is to run specific detectors. So rather than running all 90 plus detectors and trying to prioritize and understand which ones are really bugs and which ones aren't, perhaps the best way would to instead approach it this way, where for instance, if we are looking at an ERC 4626 vault, which is not important that you understand the ERC20, but just that, ERC standard, that you might be familiar with potential issues with it, like when you deposit you want to be careful about the rounding direction because you might make the deposit favorable to the user, which would then allow them to potentially take out more money than they put in, which would be an exploit, right? And so if we're familiar with this standard and we know of like potential issues with it, we can sort of grab out of this bag of detectors and we can say which one could help me like find potential issues that I'm concerned with. And so here we would ask Slither, can you detect instances of divide before multiply? Because if you're not familiar with like doing division on the result of multiplication can result in the loss of precision and thus the rounding error that we're talking about. And so the thing to learn from this is that the best way to use stack analysis tools is to first understand potential concerns and then see whether or not the tool has surfaced anything related to those concerns, and then you can go from there and prioritize them that way. The second way I would offer to use Slither more productively is how you can, or even just the medium or the way that you review the results. So by default, most people interact with Slither through like a CLI or their terminal, right? And they're looking through this output, and it doesn't have as much context, and you can't really quickly like use like an LSP like functionality, like go to reference or stuff like that. You don't have a lot of context, and one way to get around this is when you're triaging static analysis results is instead of going in your terminal, you can use Serif. It's the standard file format for static analysis tools, and it has really powerful editor integrations. And so you can, for instance, use this Microsoft Serif viewer, and instead of reviewing results in your terminal, you'll get these nice IDE diagnostics. And some of the nice things about this are that you can mark results as valid or invalid. You can take notes about them, like maybe you're still undecided and you're not sure yet. And you can also share these notes and results with collaborators. So if you work on a security team, you might kind of do division of labor and say like I'm going to look at these, and you commit it to a repo, and your teammate pulls it down, and now you guys are making progress through the results over the audit. And so here's what the output looks like. You might be in VS Code, and you get this kind of squiggly line, like if you're familiar with Google Docs, right? You get this red squiggly line like, hey, there's a spelling error. Well, Slither's going to give you a message like, hey, there's a vulnerability here, right? And so while you're reviewing your code and making progress as is natural to you during code review, you can quickly go through these results and sort of have things to investigate as you're doing manual review. And here, this would be definitely a bug, but sometimes you might say like, hey, this isn't a bug, and you just keep moving on with your code review, but you were able to very quickly in your editor identify whether or not it is indeed a bug. So the thing to learn from this is that the best way to review your static analysis results is in your editor when you have like full context and ability to explore your code base. So as I said earlier, we didn't have much time to go into the internal details of Slither and like how we added Vyper support. I would love to talk about it. We might do a live stream, which you could find on Cheryl media channels. But as I said, we added initial language support, and there's always going to be with like with Solidity, like things that change over time or things that we need to increase the accuracy of. So like one instance of this in Vyper is that there's like 3 or 4 different ways to use the built-in low-level calls, and it changes the return type and the behavior. And so those are things that we have to model in Slither in order to expose it to people who are writing analyses to make sure that they understand the behavior of the code. So those are the kind of things that we will continue to work on. Also, Vyper is still rapidly changing. Like they have a planned update and the next breaking release of 0.4 for some sort of module system to be able to reuse code. And so that's something that as the language evolves, like we need to keep up with. And the third thing that we'd like to pursue upstream improvements in Vyper. So one instance would be called reference declarations, where when you have a variable used, you can see like where was it defined. And this is something that not only would benefit Slither, but also peripheral tools like language server implementations. And this is just stuff that, like, as compilers mature and their AST, the abstract syntax tree matures, it makes all downstream tools better, and that's something that we would like to invest in, and we've already started work towards that with the Vyper team. The last thing would be that right now we have these 90+ detectors. Many of them are language agnostic, but we also want to add Vyper-specific detectors, and one instance of this would be just like the order of evaluation is a little bit different than Python, so we want to help people get rid of foot guns and identify that. And that's all I have time for. So if you'd like to talk to me after, you can find me back at the Trail Bits booth. But thank you for your time.